Saucier, this is a video lesson on the anatomy of a sinusoidal wave. I'm going to sketch a sinusoidal wave. Not parent sine, not parent cosine, but a transformation of either parent sine or cosine. Sinusoidal waves have reliable properties, and we have names for the features of such a wave. One feature that all sinusoidal waves have is they have extrema. Extrema is a fancy word for extreme values, and those extreme values, can come in two different varieties: maximums and minimums. The extrema on this wave are easy to observe. At the crest or top point, we have a maximum value, and the same maximum value repeats as the wave repeats. We can abbreviate maximum as max. At troughs or low points, we have minimums. We can abbreviate it min. In between a maximum and a minimum value, we have a midline. The midline of a sinusoidal wave divides it into a top half and a bottom half. And the midline, the distance from a maximum to the midline, is the same distance as the distance from a minimum to the midline. And that distance from max to midline, or from minimum to midline, we call the wave's amplitude. The interval that it takes to complete one cycle of the wave, no matter where we start and where we finish one cycle of the wave, that distance is called the period. I could choose any point on the wave. The interval that it takes to go through the cycle back to the very same location on the wave is the period of the wave. A transformed sine or cosine function has the equation of this form: y minus k divided by a is equal to sine or cosine of theta minus h. The variables in this equation are y and theta. The variables are the ones that we would label our axes with. Theta is an angle measure, horizontal axis. Y is a vertical measure, vertical axis. We could solve this equation for y by multiplying both sides by a and adding k. When we do, we get y is equal to a sine of theta minus h plus k. If y and theta are the true variables of this equation, the other letters are what we call the equation's parameters. The parameters are what modify the parent version of this equation. And if we modify the parent version, we get different values for the extrema, the amplitude, and the period, and the location of the midline. A, h, and k are called parameters. More specifically, this value a is the wave's amplitude. Very directly, if we knew that the amplitude of this wave was 3, that would be the distance from the midline to a maximum, or from the midline to a minimum, the same value, 3, then the value for a in the equation for this wave would be 3. H, the number that we add or subtract to the horizontal variable, is the amount that we shift the function left or right. H is called the horizontal shift. And in some science applications, the horizontal shift might also be called the phase shift. The value in equation k that we add or subtract to the vertical variable y is how much we move the wave up or down. K is the vertical shift. It's easy to observe the vertical shift in a wave if we can identify where the midline is. In this case, if the midline were up 2, then the vertical shift would be 2. Sine and cosine, the parent functions, have a midline of 0. The horizontal axis is the midline of parent sine and cosine. So if we see that the midline has gone up by 2, then we know that the vertical shift was up 2. With a reminder that sinusoidal waves can be thought of as transformations, we can see that cosine can be defined as a transformation of sine. Both cosine and sine's graphs are called sinusoidal. Cosine doesn't have a special or different sinusoidal wave. It's a transformation of parent sine. More specifically, we can see if we compare sine, which starts at its midline, heads up, and then completes a period by coming back to the midline, and we compare that with cosine, which starts at its maximum, heads down, and then back up to complete its period, we can visually see that cosine is the parent sine wave that has been horizontally shifted left by pi over 2. So its equation, cosine of theta, could be thought of as sine of theta with a leftward horizontal shift of pi over 2.